motion car crash, looking at conservation of momentum, as well as the impulse that each of them gets. You can see that the amount of space and metal here, that the bigger that would be, then it increases the time of the collision, which actually reduces the force. Both cars do have approximately the same mass. They're going about the same speed, so they have momentum going in both directions of equal magnitude. So the system doesn't have any momentum, which you can see that when they collide, there's not going to be any momentum afterwards because there really wasn't any for the system. So they're going to hit, slow to a stop, right? We actually want that increase of delta T. You can see that there are watermelons in there that fly forward and then smash. This wheel even comes off the ground. There must have been a little torque to almost want to make that thing rotate a little bit, meaning the collision must have had a pivot a little lower than that. Here's kind of a close-up view. And again, this would be fairly inelastic, and you can see there's really nothing that happens afterwards because their momentum was so close, and almost all the energy gets dissipated in the collision that there's just not any energy left for them to kind of bounce back. Almost all the energy is lost due to heat.